This video was produced to introduce basic information about the operation of standard equipment, machinery, and tools found in a metal shop. A video cannot replace in-person instruction. Watching a video does not replace experience, and this video does not introduce every possible situation or circumstance involved in using equipment successfully and safely. I do not assume liability for damage or injury resulting from the information this video provides. Continuing to watch this video affirms your agreement to waive any claim of liability you may have against me by implementing any procedure or recommendation contained here. Shops are inherently dangerous places full of equipment that can cause injury if not used correctly. You must use care and pay attention when using equipment for your own safety and for the safety of those around you. Dress appropriately to work with equipment, wear shoes that protect your feet and clothes that cover your skin, remove all loose clothing and jewelry, wear eye protection at all times. If you do not feel confident using a piece of equipment, don't. Ask for help or guidance from someone with more experience.
This is a guide to the basic hand tools that you're going to encounter in the metal shop. The combination square is adjustable for different measurements. Oftentimes it has different units of measure on it. Some have been stamped. Really good ones have been etched, so there's no distortion in the blade. They have a track that slides back and forth. And you can use them for making right angles, for measuring, for making 45-degree angles. There's a level. Some of them have a scribe in the end, a secret scribe. To move the blade, loosen the knurled set screw, and the blade will slide back and forth. Before using, make sure you tighten the set screw so that the blade isn't wiggling around and you actually get a right angle. You can pull the blade straight out, and most people struggle to get the blade back in. So I want to tell you how to do that because it's really not that hard. You just have to make sure the groove in the blade is lined up with the tooth inside the handle, which comes in from one side. And if you loosen the set screw a little bit extra, you can just insert the blade and wiggle. It'll slide right on, and then tighten the set screw. The reason people struggle is they have the blade backwards, or the set screw is so tight that it won't let the tooth line up with the groove. These are scribes. They're used for making a line on a piece of metal, scratching an intentional line into the metal. The most common ones that most people in the shop have are double-ended, a right angle at one end, straight at the other, a handle in the middle. A lot of tools in the shop use a similar arrangement, a scribe and a clamp that has a curved end to get the scribe on an angle and a straight end. A very cheap scribe is a metal one that has an inserted tip. They almost never have their tip. This one doesn't, and that's because people have used it wrong. I'm going to come back to that. My scribe from home is twisted, feels nice in the hand, pointed on both ends. They all work. They should be sharp. So a sharp scribe will stick in your nail a little bit, won't slide off. The reason you want it sharp is if you use your combination square and your scribe to make a line on a piece of metal, you want to be able to see that, and you want to be able to do stuff with it. I'm using a piece of wood just to elevate my metal. Usually I would just use the table edge, but that will be off camera. So if I wanted to scribe something on my piece of aluminum, which scribe should I use? It's going to be a really clear straight line, and if my scribe is sharp, I can feel that line. My scribe will actually sink into it. If I had a specific point I wanted to indicate, I could actually find that exact point by running the scribe through the lines until I find that clicking point. So the accuracy of your measuring is only usable to you if your scribe is sharp. If you start with that point in the right spot, every tool you use after can register back to that, and all of your operations will be accurate. These are center punches, which are the next things I might use to do something with that accurate mark. This one has a very wide tip, and it is not sharp at all. So it's not going to be useful for very much. It'll produce a really lovely little dimple in the metal, but there's no way to be accurate with that. This one is sharp, and it also should be sharp enough to not just slide off my thumbnail. If it isn't sharp, I wouldn't use it. This has a nice knurled handle. These are a solid piece of steel that you can hammer on. The reason this scribe has no more tip is that someone has used it, and you can see here, as a center punch. They've put it down and hit it enough times that they dulled the tip, then broke the tip. And so now this is a piece of garbage. But before it was a piece of garbage, it was a scribe that a lot of people unwittingly used and had inaccuracies as a result. So if I take my sharp center punch and carefully find the intersection of those two neat scribe lines, it sort of clicks in place. and I know that I've found that. I can then tap my center punch, and I've got a reference point that I can use for drilling, for punching, for all sorts of other operations that will be in the right spot. If I use the dull one, let's just see what it would look like. I can use it now because there's a nice point there. You can see what it did. It made a really nice distress mark that I could use for something, I don't know what, but not necessarily for something accurate. This is a bench pin, a block of wood that I can put in the vise, and in every other video I've called it the wrong thing. It's a bench pin, it's flat on one side, angled on the other. These are hammers, you already met one. This is a rawhide mallet, which is soft, so you can use it for actually hitting metal. You'll dent the metal, but it will be kinder to your metal. It's also good for tools that weren't designed to be hammered with a solid metal surface. So it's a little bit more forgiving. This is a ball peen hammer. It has the peen at this end is ball shaped, and it has a flat side. These are useful for just general hammering, but also for setting rivets, because you can control where you're hitting and what you're doing to the metal as you distress it. These are dividers, which are super useful for people who don't like to measure. These also should be sharp, and you'll find a wide variety of them that are sharp and not sharp. Same test, thumbnail. The reason they should be sharp is with your combination square, you have all the tools you need to cheat at measuring. Some teachers would teach their students how to measure. I'm not good at measuring, so I teach cheating instead. If you use your combination square, you can actually set the divider into the rule lines because they're etched or stamped deep enough, and you can rock it back and forth to make sure you've got it exactly right. And so there's 1 inch. I've set my dividers at 1 inch, and then I can do 1 inch in from the edge of anything. So this is a problem if I haven't cut my metal accurately. Every 1 inch I do from the outside edge will not line up on the inside. So it's not the best approach for measuring. In the layout conversation, we'll talk about that. But for most of what I do, it's accurate enough. And then, armed with my 1 inch divider, I can really quickly scribe a 1 inch situation around the edge. That's good if I'm making a tray, if I want to use the corner notcher. There's any number of reasons I might want to do that. I think I'm working with a piece of metal that's not even a rectangle, so this would be a really bad scheme for accuracy. But you get the point. The divider is also useful for drawing circles, of course, if you have a nice center punch in the middle. Now I'm using that sloppy center punch. You can get a circle. You can also use a divider for more complicated situations like making equilateral triangles. Really, really useful tool for finding cheats around math using basic geometry. They come in all sizes, huge and tiny. Because I want to use the airplane shears later, I'm going to set up a piece of metal to do that using the tools we've looked at so far. I want to make a 3 inch circle. So I'm going to first set my divider at more than 1.5. I'm going to scribe a center point. I'm going to scribe it nicely. I'm going to center punch a little bit there. That will hold the point of my dividers. I'm going to do the outside circle, which is a little bit bigger than my 3 inches. I'm going to reset my divider at 1.5. And that's going to give me concentric circles with a little bit of waste. And I'll tell you why later. Okay. If you have trouble seeing your scribe lines, you can use a Sharpie and scribe through it. You could use Dicom, which is a blue dye that smells terrible that you must use in a vented area. But for most of what you're doing, and with your young eyes, that should work okay. These are hand shears. They're also called airplane shears, and there's 3 kinds. There's the straight one, straight blades, straight handle, cutting straight. These are horrible tools. You'll never get anything nice with these. And students always think they could just get away with doing their whole project by hand with this, and it's sad. But for thin metal, they're quite easy to use. They're like scissors. They make a horrible little curved shard of metal with a serrated edge, because one of the ways these cut is by having little teeth. So a nasty piece of metal, a nasty piece of metal, but useful for fast cuts and useful for not straight cuts. And that's where these come into use. Red and green, they're often called righty or lefty, not so much based on my hand, but based on the way they cut. So if you're cutting a circle, let's see if we can get this on camera. When I cut with this tool, this piece comes up over the blade, which means I can cut in a counterclockwise motion and keep the metal out of the way. Red handle. Green handle is the opposite. With the green handle, the metal is going to go up over the right-hand side, which will allow me to cut in a clockwise motion with the metal staying out of the way. But with both of these, again, you can see it's a really nasty edge. You're very likely to cut yourself on that. It will never feel nice. There's nothing you can do about it. The reason I scribed 2 circles on this piece of metal is that it is a rookie mistake to draw your circle and cut your circle with one of these. You distress the metal so much and you can't clear the piece you're cutting out of the way. So you should always do this in 2 passes. You should cut outside of where you want with a little bit of extra metal so you can be sloppy. You don't have to be all that careful. The metal can do whatever it needs to do. Why do I stick my tongue partway out when I'm concentrating? I also, just as a courtesy to myself and others, would then go to the shear and cut this off so that I don't have this in my life. Because if I put that anywhere, my locker, my bag, down, it'll be a problem. So now I've got a very, very rough, crude circle, and I can go back along my proper line with more care and better lighting and my reading glasses on and cut that out. I don't want to make you watch me do this. I'll speed it up. That's still not perfect. I would need to file that to make it perfect. But for some things that might be good enough, and you can see the edge is serrated and horrible. So those are hand shears. As with many hand tools, really useful, but also tools always leave their mark on the things that they're creating, and sometimes those marks are really awful. If I were to file this, and there's a whole filing video, I would put this in between 2 pieces of wood in a vise and file sections at a time. Because if I put this just on the table and aggress it with my file, I could do it. It's not going to sound nice, it's not going to feel nice, it's not going to produce nice results. But there you have it, a circle with a center punch in the middle and a couple of scribe lines. They have a lock on the side that keeps them from opening. This is really, really important because when you put these in the drawer, if you haven't locked them shut, they will open in the drawer and prevent that drawer from ever opening again. So be sure before you put them away that you've actually closed them all properly. They also have different areas they live in so that you don't have to go hunting for which is the right color handle. Files also get their own video, but just to put them in here, there's a really wide variety of types of files. There are big, huge files. There are round files, square files, triangular files. I couldn't find one. The handy file, which is the one you're mostly going to be using. Many files just have a point. It's called a tang. I call it a spike. That's designed to sit in this handle really tightly. I don't own any handles at home. I only have sharp spikes. That's why the handy file is nice. It sort of has a handle. Some of these are very coarse, the larger files especially, and some of them are quite fine. There are also very small files, jeweler's files, that are tiny and One of the other mistakes I see students making all the time is trying to file in a really aggressive way to remove a lot of material with a little teeny file. I can't tell you how often I see people just doing this. You know, use a real file, put it in a vise. These are very good for finish filing, for making a smoother edge, for filing inside things. They're really not good for large surfaces. They also have no handle. They're not so difficult to hold, but there are handles if you want one. A couple of other tools that you'll encounter. The hand punch, which gets its own video because it's such a mighty piece of equipment and gets so much use in our world. Makes a hole. So check out the video for that. I had to make a hole to show you the next two. These are reamers. This has a screwdriver handle. This has a T-bar handle. And they're designed for making holes bigger, which we'll look at more when we look at making rivets. But I can put this in the hole and twist. It only cuts in the one turn, and it makes that hole bigger. It also makes it slightly tapered. So if you don't want that taper, you can go in from the other side and make it a little bit more parallel. These are really useful if we have punches set up for an 1/8" hole and you want something a little bit bigger and don't feel like changing the hole. Also, 1/8" rivets don't always fit in an 1/8" hole. Sometimes you just have to open it a little bit. Another concentric hole affecting tool, that was a good sentence, is a hand-mounted, looks like a countersink that you'd use on the drill press, but it's actually got three blades, and it's designed for taking the burr off or just slightly chamfering the edge of a hole. This one's very sharp. This one is not. So I'm going to use the sharp one. So that gave that hole a really nice finished edge. It would also give it a taper if you were trying to seat something in that had an angled surface. So there are some other hand tools. There are a couple of mystery tools that you probably don't need to know, but you'll encounter, and so you should at least know what they are. This is a scraper. It's got 3 sides and sharp edges, and it's not useful at all on tin-plated steel. It will do nothing. If you naively think I could just sit here and whittle away all of those nasty edges, you're wrong. But on aluminum or copper or brass or silver or gold, they're really useful. It's like a potato peeler, and it's just going to take a very small amount of metal off of the edges. And that's a nice way to round the edges over. It also gives a really finished look to an edge. So we don't use them much in here, but that's what they are in case you encounter them. Don't use them as a center punch. Don't use them as a scribe. That's not what they're meant to do. There's another one that's shiny everywhere and smooth, and that's a burnisher. That's another tool that's used a lot in jewelry and not so much in here. But there are times you might want to compress an edge or round over a piece of soft metal on the edge. If you're running this in a track and you want to remove the resistance, why else? I don't know. It's how jewels are set in a bevel setting where there's a little wall around the stone and you press it in. So it transfers its smooth, hard surface onto your not so hard metal. Again, don't really need to use it, but it's here, so you should know what it is. There are also some hand tools that will mimic what you can do with larger tools. If you don't feel like waiting online for a break, or if you're just sketching, you might want to use a hand brake. This is a basic one. It's just 2 flaps. I can just clamp this in here and bend it. And as with everything else, it gives you results that might be good enough, but might not be good enough. So I've bent the piece of metal. It's okay. It's not the neatest bend. I could improve upon that if I put it in here and support it while I bend it. Take a piece of wood or something and bend it in a more controlled way. I'm concentrating the movement into a smaller area, so I'll get a sharper bend. So you can see it might not be as useful as the larger finger brake, but for quick sketching and bench work, it's a pretty nice tool. There's also a vice grip version that has big fins that you can clamp and bend. And this is especially effective if you use 2 at once. But they have real limitations. They're only this wide. They're only that deep. So you really can't get the full range of bending options you can with bigger tools. You will also encounter a charming little device that anyone who's done home repairs will recognize. It's a tubing cutter. It's made for plumbing. The larger ones are used for plumbing. This one is used, I think it was actually made specifically for the water cable that goes into refrigerators, small copper cable. too small to cut with a bigger tubing cutter. But we use it in here a lot for making tubing rivets. This is a piece of brass tubing, and I could cut it a few ways. I could cut it with a jeweler saw, which if you like your jeweler saw is the best way. You get a nice straight square edge. You cannot cut it in the wire cutter because that will just squish it. But this uses a support below that's V-shaped and a blade on top and rotational movement to cut a piece of tubing. It does condense the tubing in around the cut, which sometimes is actually what you want. So it's really easy to use. You just get the blade into the metal. If you tighten it too much, you won't be able to turn it, especially if you're an old man who doesn't have good grip strength anymore. And then you rotate it a few times and then tighten it a little bit more. You can rotate the cutter. If you can grip the tubing enough, you could rotate that. So there's the edge. It's a really beautiful edge. It's got a slight bevel to it because it's compressed the metal in around the cut. If you have to make lots and lots of rivets, tubing rivets, this would be a good tool for doing that, especially if you set up some sort of stop so you didn't have to measure. I don't know what else there is. I think that's it.